Hello there. So we're going to go straight into conditional probability from Venn diagrams today, which is just like what we did before with two-way tables. When I say two-way tables, their real name is a Carroll diagram, which is rather great because they were invented by Lewis Carroll, who's rather more famous for writing The Adventures of Alice in Wonderland. And you may wonder about that. What's someone, a mathematician, doing writing something like that? But actually, Alice in Wonderland came about from him exploring in a sort of novel form the idea of wormholes and things, which he was working on. So he's a very influential mathematician. But anyway, we can do the same idea with Venn diagrams. So we're starting off with the probability of A there being 0.55, probability of B being 0.4, and the probability of A intersection B being 0.15. So have a little think about that one. Pause the video, and then hopefully what you've got should be something along these lines. So if we start off, we've got our box. So A is going to add up to 0.55, B is going to add up to 0.4, and in the middle we're going to have 0.15. So if this is going to add up to 0.4 in the whole of that box, this must be 0.25, and if A is going to add up to 0.55 altogether, it would be another 0.4 on top of what is there. And there's one more thing to think about, is what's the probability of neither of those events happening? And in order to do that, all we've got to do is add them all up. 4, 6, 7, 8. So 0.8 of all that happening. So if we take all of that happening away, the probability of what doesn't happen is what's left over. And so there's 0.2. And then we just have a few little questions to answer on that. So here's our 3 questions. Pause the video, have a little go, and then see whether or not you agree with me. So the probability of A given B means we're given that B happens. So all we've got that could happen here is everything that's in B, which is adds up to 0.4. And if we know that, the chance of getting A as well would be 0.15. So that's where I'd start, and then we just need to simplify that fraction, which you can do just by chucking into your calculator, or we can just have a bit of maths fun, can't we, by multiplying them both by 100 and then dividing them both by 5, giving us 3/8. Now, probability of B given A union B. So we're saying A union B, which is all 3 of those together are going to be our denominator. So if we add all of those up together, we get 0.8, don't we? Because we talked about that before. And we want B. So B is either of those two, which is actually 0.4. So we're talking 0.4 over 8, which simplifies to 1/2. And finally, probability of not A given it's not B. So what's not B? Well, this is the last. So not B means we've just got this left here, haven't we? So 0.4 plus 0.2 will be our denominator, or 0.6. And we don't want it to be A. So not A is going to be that, isn't it? So 0.2 over 0.6 times them both by 10 gets you 2 over 6, which simplifies to 1/3. Now, you may have noticed Mrs. G's influence earlier on in the video when she insisted I introduce her long finger into proceedings. This has all happened because I told her that this stuff that we were doing now was so easy that even she could do it. And that's not to say she's not intelligent. She is. She just doesn't really think much of maths. And so I proved it to her. She enjoyed it. And then she got rather interested in how I should present it. And she thought the long finger was important. And then she wanted to pretty the maths up a bit with some flowers. So anyway, here we are. Exercise 2C. I'd like you to have a go at 7, 8, 10, 11 and 12. 7, 8, 10 and 11 will follow on the screens afterwards. But we're going to do 12 together. Just because that's what I'd like to do. Right, so have a little go at this one. Given that the probability of A given B is equal to the probability of A dash or not A not happening, find the values of C and D. So as ever, pause it, give it a go. Right, so I'm going to have a little go at defining what I think both these. I think this one might be easiest to think about. So the probability that it's not A is going to be one minus D plus 0.2, or you could say, yeah, or no, 1 minus the probability that it is A, isn't it? The probability it is A is 0.3 plus C, which is the same thing as taking 0.3 away from 1 would be 0.7, and then we'd still need to take away C. Now that probability is going to be the same as the probability of A given B. So let's think about that as well. So given B is C plus D, isn't it? So the probability of A given B is going to be C plus D on the bottom, but I also know that the probability of not B is 0.3 plus 0.2, which is a half, isn't it? So if they add up to 0.5, these two must add up to 0.5 as well, so the whole thing adds up to 1. So I'm going to say 0.5 is my denominator, and what I want is the probability of A given B. Well, that's actually C, isn't it? So I want C over 0.5. Now if these two things mean the same, I can then make a nice little equation where C over 0.5 equals 0.7 take C. Multiply both sides by 0.5 or a half. Could look like that. Then I'm going to have half of 0.7 is 0.35. Take C over 2. Add C over 2 to both sides would give me 3C over 2 is equal to 0.35. Double both sides would give me 3C equals 0.7. And therefore C would have to be 0.7 divided by 3. If I was to times both of those by 10, that would give me 7 over 30, wouldn't it? So that's my C. Then if I want D, I know that C plus D is equal to 0.5 or a half. Let's just call that a half to keep all fractions. So I'm saying that 7/30ths plus D is equal to a half. So D is going to be a half. Let's split that into 30ths, 15/30ths. Take the 7/30ths is 8/30ths. So I've got D being 8/30ths and C being 7/30ths. Okay, all I've got to say now is remember now to go on and have a go at exercise 2C, questions 7, 8, 10, 11. And that's all for now, folks. Cheerio.